Hey, I have a second channel, Cube Compium TDX. Hey everybody, so here we have this Bestec ATX-300-12Z power supply. There's your spec label if you're wanting to know the specs of it. So this unit, this is the one I recently featured in a video where I had tested using a lab bench power supply, tested the outputs to see if there's any shorts, and didn't find any shorts on the output. This unit, the 5-volt standby, does not start up, and therefore the whole rest of the unit also does not run. I've had this unit since probably 2014. I've had it in a packed away in a container full of random power supplies that I decided I would probably investigate someday. And I want to see if I can get this one to work, but I'm curious to see what's going on. Maybe I can find some reason why it failed or why it's not working at all. I don't see any signs of failure, at least on the top. No burn components. Heck, the capacitors look fine. None of them are actually bulged. But I may replace 2 capacitors up here in the 5-volt standby section to see if I can get this thing to start. Maybe that would be our problem. Capacitors are actually a really common issue on these Bestec power supplies. I mean, I've been doing videos of these things for years. I've been recapping these things for many years. And they're great PSUs once you recap them, with one exception. The ATX-300-12Z, that's in E-machine systems, that's the one you want to avoid. But even those, if you're really into electronics, you can actually rebuild the 5-volt standby supply on those. If you ever just look up badcaps.net forums for a post from Everell. You'll see a thread on where he actually re-engineered the 5-volt standby circuit on the 250-12E to make it safe. Now this unit here, as well as the 312E and the 250-12Z, they all have an IC controlled 5-volt standby. The IC is actually right down here. Now I should mention, be careful poking around in one of these things, because these capacitors here can hold a charge, and it could kill you actually. 9 times or 9.7 times out of 10, the unit would be safe to work on probably within an hour, because there's, of course, you got connected load here that's off this DC supply, and you've also got bleed resistors on these 2 primary capacitors. I've already checked, and this unit is indeed discharged. This was one I was a little concerned about because, well, the 5-volt standby wasn't working. So that being said, I'm going to take out this circuit board to see if I can locate any damage on the bottom side of the circuit board, because these newer units, or at least these newer units, they tend to have surface mount chip resistors on the bottom. They tend to sometimes have surface mount passive components on the bottom, and of course you got to take the actual circuit board out, at least on this unit you do, to see the bottom. The 312E, you don't. You just take the clamshell case off and you can see everything you need. I wish, to be honest, I wish all of these supplies were that way. It makes them a whole lot easier to service. Alright. Let's get this circuit board out of here. Let's see if I can spot anything of concern. Okay. Now we're looking at the bottom of the PCB. Oh, looky here, guys. Let's see, a problem for sure. We have what appears to be a blown trace right there. It looks like there used to be an SMD component there, so it's completely gone. Completely gone. Nothing left over. Trying to see what that is connected to. We got this resistor here. Yeah, that's really interesting. Yeah, you can see, you may be able to see right there. Something definitely went wrong right there. The rest of it looks fine. Now the crazy thing is, every time I've plugged in this power supply, it's never like blown up or anything. No pops or nothing like that. Now I did check this thing for voltage, DC voltage, before I opened it up, or at least before I started working on it. Check it again. Yeah, we're fine. Yeah, we got just millivolts on those primaries. Yeah, guys. I'm not exactly sure what went wrong right there. So that's why I'd say that's why it's a good idea if you're troubleshooting a power supply that's not working to open it up, take the board out. Like I said, I'm not sure what was there, but we definitely had an explosion for sure right there. It's probably what yeah. So the this power supply unit came out of a part system from years back. That was given to the of course donated to the Google Computer Works store, and so whoever had this computer last with this power supply, this OEM power supply in it, probably I guess we can say that they were definitely frightened for sure. So I want to check and see. I want to ohm up this fuse here. See if the fuse is blown. Because I mean, if you have a primary short to ground, you'll typically take out the fuse, if not your house circuit breaker first. And sometimes the circuit breaker will outpace the fuse. Fuse is intact, so it didn't blow the fuse. So whatever fault this was here, it must have cleared itself when it blew like that. And you look right here inside the power supply case. On this plastic here, you can see right there. Got a nice little blowout right there. So I mean, I do actually have another 312Z. It's actually my I used to call it the Test Tech years ago because I use it for testing computers and stuff. I totally recased it. The case it's in actually used to be for like a Raid Max supply. This was kind of just for fun kind of project, and to give it, of course, give it a case with an on-off switch, all the good stuff. But I'm going to actually open up a 250-12Z and see how similar it is, at least in this area. Maybe we can figure out what went wrong right there. So first, let's get you a close look at the blowout. Okay, there's you a better look. There you go. You can see pretty nasty. If we look here, you can see definitely had a nice little blowout there for sure. Okay, so now we have a here we have a Bestec ATX-300-12Z. This is the older cousin of the 250, or excuse me, the 312Z. So these are both HP OEM units. This unit here, interesting to note, is one I had to replace the power socket on a long time ago. I think the computer this power supply came in, the socket on the back was actually broken. It was loose, so I replaced it with this one. That's why it's externally installed like it is. But this unit served out its several years of service, and whatever refurbished computer or what have you I installed it in. And now we got some failed Jamicon capacitors in there that need to be changed out. So it's been in my to work on container. It's been in my to work on container for quite some time now. So we're going to open this one up and have a look at that same spot in the primary and see if we can figure out what blew up in this other one. So it looks like, yeah, this is interesting. Let me get you a view. So here is the 250 12Z's primary. Now this unit here has been unplugged for quite some time, and these are actually really similar. We're looking right here. This is the spot on the 312Z that had that nice little blowout. See right there where it actually blew up. So it looks like maybe I'm going to come to the conclusion, guys, that maybe some foreign matter might have got in there and caused a dead short between the DC primary and ground. So this DC primary has, I want to say, up to 370 volts DC on it. I mean, yeah, we could be talking about a really nasty path to ground there. So maybe this unit can be repaired. Maybe it can, because I'm beginning to question. You know, if this trace here got blown out completely, then that would mean that perhaps the 5-volt standby IC was not getting any power from the DC primary, because the DC primary feeds not only, of course, the main switchers to run the main rails, it also sends a separate supply over to the 5-volt standby circuitry. The 5-volt standby rail is actually like a power supply in a power supply. It's separate from the actual, power supply. It generates 5 volts DC for standby. It powers like the supervisory chip and all that good stuff. It also the transformer for the 5-volt standby also has a winding that feeds a second output. So it's like an auxiliary. So what I'm going to do is I'm going to get the meter and check for continuity between here and here. Let's see. I want to see if maybe that's actually, if we're actually got a blown connection there, because I could actually repair that. I could just use some solder to sort of bridge that in. let me see here. Yeah, you can actually see it. Good. So from there to there, we do not have anything. Whereas on the 250-12Z, we have continuity. So we got to make sure that we don't have continuity between this and ground. And I'm set this up high. Yep. Just making sure that we have nothing between here and there, because yeah, that's a dead short. So what I'm gonna do is I'm gonna get a Q-tip, see if we can clean that up, and I'm gonna actually solder that back together. I'm gonna make a solder bridge right here. You get those connected back together. And what I'll do is I'll go and throw this unit back together and back porch test it. And you probably know why I'm going to back porch test it, because if it blows up outside, not inside. You know, it's interesting that it didn't blow the fuse. I can say, guys, the DC primary on this unit does work fine. I think I mentioned in my last video talking about this power supply. When I plug it into AC power, of course the lights, you might see a brief little flash in the light. It's not like a brief little dim, like when you turn on something heavy like a vacuum cleaner, for example. You know, the power supply units, when they first see 120 volts or 240 volts, whatever, there's a pretty high demand for current, and it's limited by this NTC thermistor. It's right there. You can see it right there, little green thing. It's the NTC thermistor. When it's cold, its resistance is high, and when it heats up, the resistance goes down. So it helps to limit that inrush current, which could be the reason why the fuse didn't blow on this. The NTC probably absorbed some of that energy. Well, I can't say absorbed, it probably limited some of it. Alright, so let's see if we can clean that up. Okay, so I'm going to take some rubbing alcohol here and try to clean this up. Yeah, we definitely got separation there between the two traces. For sure. So I'm not exactly sure what caused that to happen. Maybe there was a piece of solder that didn't belong there. Not really sure, but it blew it out pretty good. Like I say, it completely separated the trace. So what we can do is we could do one of two things, actually. We can bridge that spot right there. I'm just looking at the other one to see how it's done. Yeah, it's really bizarre what actually went wrong there. Like I said, I'm thinking maybe some foreign object got in there and caused a dead short. Could have been maybe a ball of solder. I mean, that's the best I could guess at it. Maybe a loose ball of solder had got in there and caused that to happen. Or maybe there was a short somewhere else, which I kind of doubt. But I mean, the only way to really know for sure is to put it together. I mean, bridge that gap in the trace with some solder and just see what happens. I'm going to actually use a little bit of sandpaper right there. Sandpaper will probably work a little better. Oh yeah, much better. Okay, so now what we need to do is heat up the soldering iron and just put a little solder right there and close that. We'll actually bridge across that little gap to reconnect those two circuits. Alright, so soldering iron is heating up, and I'm going to make a bridge, a solder bridge, right there across those two traces. Because if we have a look at the Bestec 250-12Z, try to put them side by side so we can see. Alright, so right there is the connection to the heatsink. You can see that's what we're trying to do, is reconnect this part, so that way it'll conduct. And if there's no other issues with that circuit, then perhaps the 5-volt standby will come to life. But if there are other issues, it'll probably end up blowing out other components, and at that point I would just say this unit's not repairable. I guess if you really want to put the extra effort into it, you could repair it, but so we're going to add some solder. Now if it doesn't stick, I'll use some flux. Well, there's flux in it, so it should adhere. You definitely don't want it looking really nasty by any means, especially on the primary, because that's where things will blow up. See, pretty much we're having to tin the trace as well. You know, once you get to 10, the solder will pretty much take care of the rest. Okay. I'm just reheating it a few times to make sure that it does indeed stick. Okay. So now I'm going to recheck for connection between those two traces, or points rather. So now make sure we can see it. So now between here and there, we now have a connection. We previously did not. And it's going to check between the DC primary and ground, and it's open circuit. That's what we want, open circuit. For example, I'll go back over and and do the same with the 250-12Z. Again, same thing, dead short. So now we've reconnected those two back together. Provided there's no other failures in this power supply, I do want to say that 5-volt standby will come to life, and this unit will probably work. So it'll be just a matter of putting this thing back together. Okay, everybody. So before I put this back in the case, I did want to mention I went back and reviewed my video footage, and when that little bit of solder popped, it left a little piece of solder over here. So got that cleaned up and checked everything else to make sure there wasn't any loose bits of solder in places where they didn't belong. That's one thing that can happen with solder. Sometimes it can, if there's like an air bubble inside the solder, it can, do that and make it go everywhere. So again, as I mentioned, got that loose bit of solder off this trace over here, and got this one bridged up. So I'm going to go ahead and install this power supply back into its case and see how it goes. And the thing is, the capacitors, although they're not the best, this thing could need a recap in its future. But at least for now, I'm just going to go ahead and put it back together and see if it works before I decide to invest more time in it. Another thing I don't like is they used on this one. They use that yellow glue, which when it gets hot, it can darken with time and actually get conductive. And as I think I mentioned, it can. I've had two power supplies with this glue actually go kapow. One was a Hypro, another was a Bestec. If you look at this 250-12Z, you can see how the glue in it is the exact same glue, but it's much darker. So definitely on this one, we'll try to get some of that out of there when I recap it. But anyways, going to put this one back in its case. Alright, everybody, so I got the power supply out there on the back porch. Got our AC lead fed into the back door. I've got the PS on green wire jumper to ground, which will signal the unit to turn on. We're going to feed it power right now. And you can see we have fixed it. That's what it was, guys. Apparently something, for some reason, got into the unit, caused that fault on the DC primary, which caused it to blow. It blew that trace out, which disconnected power to feed the 5-volt standby, which disabled the 5-volt standby, which disabled the entire unit. We got the 5-volt standby working, and now the unit runs. Get you a little closer look here. Of course, it's bright out here, so you can't really see, but the LED is lit, which indicates that we have power good. Fans running, and of course it's hot out here. So yeah, that's I'd say it's good to go. I mean, I could go out there with the multimeter and test all the outputs, but the fact that it's running, I believe that's all that our issue was simply that that little blowout on the PCB. Really interesting, guys. I'm glad I decided to finally take the PCB out and actually have a look at the underside, because there's some things you simply can't see until you take the circuit board out of the case. So I'm really thrilled that that's all it was. No other damage had been done to the unit. We were able to simply isolate that faulted section and use a solder bridge to connect the trace back together, and you can see we now have a working power supply. So anyways, that wraps up for this video. Hope y'all enjoyed it. Thanks for watching. Well, everybody, that wraps up for this video, and I hope you enjoyed it. If you did, please like the video. Also, don't forget to subscribe to your channel, and be sure to tick that bell so you'll get notified when new videos are posted. Also, don't forget I have a whole lot of other interesting videos here on the channel to check out. And also, in addition, I have a second channel, CubeCompMTDX, where I have all sorts of other videos not exactly related to technology. Links to the channels are available at the end of this video. Again, I thank you for your support and thanks for watching this video.